So you guys are going through 6-2? Join us. Join us. Hi, good morning.
Good morning.
So you guys are taking a moment. You're going through 6-2. You're looking for words that don't make sense.
6-2?
6-2. You've got 1 minute. Find words that don't make sense.
I can find equations. I just can't check out the numbers. Equations, everything.
Yeah, 6-2. We're going to look at 6-2 first.
How was your day yesterday?
It was good, thank you. How was yours?
Oh my God!
It was not pretty.
It was alright. Luis, take out your 6-2. Come join us. I know. So, yes, sir. Yes. All right, phones off to the side, please, just for the few moments. Thank you, thank you. All right, let's look at question number 1.
Oh.
Yeah, on 6-2.
Oh.
Sharpen your pencil. You're welcome. What are we being asked to do on number 1?
What are we doing? Find X.
Variables. Which are the variables in number 1?
A.
A and B. So we want values of A and B.
Oh, I get it. We're going to put the, B plus 1 equals to this B. I mean, 2B.
Okay, so she's suggesting that we do B plus 1 equals 2B. You're not wrong, but the question is, why?
Because they're obviously parallel.
Because this is a parallelogram. The title tells us so. And one of our properties of parallelograms is that opposite sides are,
Congruent.
which means their measures are? There you go. Set it up. Write your setup now.
Oh, we're doing that now?
Yeah, write your setup. You don't have to solve it, but write your setup. Or write a note to yourself that opposite sides are congruent, so they're equal. So when you go back to finish it out, you know what you're doing. I'll give you about 30 seconds to write what you're going to write. The setup, preferably. Write your setup for number 1. Where's your pencil? You have a pen. Okay. Did you write your setup for number 1? Yes. All right. Let's look at number 2. Number 2, what do we have? You're right, variables.
Y and X.
Y and X. So we're going to need to find values for Y and for X. There's a lot of side conversation that's distracting. Wait for when we're done.
I just set that up.
So since we're using angles now, which properties can we make use of?
What?
What property?
Which properties could help us out since now we're dealing with angles?
The opposite angles.
Opposite sides are,
Yeah, opposite angles are congruent.
Yeah.
So then y plus 10 is congruent to y minus 40.
And since those are numbers, we're not going to use congruence, but we're going to use equals. So y plus 10 equals
Man, that's so dim.
2y minus 40.
So low. Oh, whoa.
It's the best I got right now. I'm sorry. I emailed already. Thank you, sir. A little better?
Yes.
All right. All right, so we have the setup for y. Now we need to find a setup where x is involved. Because we want to find x and y. We found the setup for y. Now we got to figure out what to do with x.
Does angle D count as x?
Angle D can count because opposite angles are congruent, so D would also be 4x.
Equals D.
4x does equal D.
X, no? Or 4x
No,
equals
wait.
x?
4x equals x? You're saying because D is X? We don't know what D is other than it's exactly the same as whatever B is.
Oh, okay. So 4x equals 4x.
Right, but that doesn't really help us solve anything because everything's going to cancel and we're going to end up with something weird
Oh,
like
then
0 equals 0 or something.
Okay.
Which, great, but doesn't help us. We want X equals a number. So what other things could I use? Do we have any other?
Wait, we can use how Mr. Peña would say the AB is A, right?
I'm not sure what that is.
It's like you have one equation
Mhm.
that has like solve for y. Oh wait, no, but that's different because
Okay, so almost like a system.
That's the one with the equals and then parentheses say y and then y and then make it 10.
like you solve for a variable and then use that
To find the other variable. Yeah, it's exactly what we're going to be doing, but the question is what equation can I write that puts this X in there?
well you can somehow put
Well, if the D
What?
doesn't have anything, we can put an X on it.
Well, we'd have to put 4X. We'd have to make it exactly the same as B. So you're not wrong in that case. You can totally do that. But which property could help us out?
consecutive angles.
Consecutive angles are
What does that mean?
supplementary.
You told me yesterday that they were congruent.
Opposite angles are congruent, yes.
Como B y D son iguales. So if we're gonna put something for D, tiene que ser por X. Pero todo se va a hacer cancelar. Nos quedamos con 0. So we can use the consecutive angle.
So we could use consecutive angles. What does consecutive mean? One right next to the other.
Oh, so A and B.
So A is right next to B. These are consecutive angles. Ladies, have the conversation later, please. Thank you. So A and B are consecutive. And consecutive angles are?
Oh, I get it. So now when we solve for Y
What does supplementary mean?
Oh, it's
equals 180.
You add them and you get 180. So since A and B are consecutive, we can do whatever A is
Y times 10
plus whatever B is,
X equals 180.
and that will equal 180. We'll have already gotten a value for Y because we solved Y over here by setting these two equal. So then whatever value you got for Y, you substitute it into here in your next equation. Write your setup. You have two equations. You should have an equation with the value at A equals the value at C, and then another equation where you're adding the values at A and B, and that will equal 180. When you're ready, let's look at number 3. What information are you being given for number 3?
The angle or side measurement
Are you given side measures?
or not, like the measurement of segments.
The segments that are inside, what do we call those segments?
line.
You're not wrong, they are lines, but more specifically,
9 seconds.
Inside lines?
inside lines?
Oh, the alternating.
I like where you're going with that one. That's going to come into play later.
A
So hang on to
centimeter.
that. But notice how we're going from vertex to opposite vertex? This is a diagonal.
I don't get it.
That's the name of it. When it goes from one corner to the opposite corner,
Oh, diagonal.
we call that line a diagonal.
Oh, so the
Oh, yeah.
diagonal measurements?
So we're being given information on diagonal measurements. So look at your properties of parallelograms. Which one uses diagonals?
Which one is what?
Which one uses diagonals? Which,
Diagonal.
the first one, we're looking at diagonals. This one doesn't have anything to do. The last one, she says, because that one has the word diagonals in it.
Yeah.
So they bisect each other. What does that mean?
That bisect.
Like,
Bias
they
like
do it into 2 equal parts. Right?
They do it into 2 equal parts. So where are the 2 equal parts?
x minus 3 and 15.
So x minus 3 and 15 are the 2 equal parts. So those two values are equal, and you can write your equation. Do so now.
What equation are we writing down?
To solve for x.
So x minus 3 equals 15?
Yep. He just told you what to write. Did you
Is
listen?
that right?
X minus 3 equals 15.
No.
Thanks.
But
Look
why?
at the top on there.
Okay. Okay, well, as soon as we're done, we'll sit down and we'll go over it again, okay?
Okay.
Okay, but for now, what I need you to do is I need you to try to focus on what we're doing, all right? And do your best to see, maybe it'll click. All right, look at the other diagonal. Are those two pieces congruent to each other?
Yes.
Yeah.
Yes, which means their measures are?
Equal.
So write the equation.
5 plus 3 equals 12.
Yes. Look at number 4.
The same.
Yes, aren't they kind of like the same? Because
They're exactly the
like
same
the four
setup.
sides?
Yep. They're exactly the same setup. Go ahead and write your equations for number 4. All right, let's look at questions 5 through 8 on the next page.
What are they?
No problem. Okay, well, that's what we're trying to walk through, so I need you to not look at the phone, and I need you to listen and try to participate and grab what we're doing, okay? Put question marks when you're still confused, but you gotta do that first step with me, all right? So put the phone away so that way the notification doesn't distract you. All right, let's look at number 5 through 8. What are you being asked to do?
Find the angle measure.
Find angle measures or find values of variables. And what information are you going to be using?
The one in front.
Oh, okay.
That shape, RSTU, and this little rectangle-y looking thing in front of the name that says this thing's a parallelogram. So we're going to be using parallelogram. Once again, we get to use all of our properties of parallelogram, so have that part of your notes out and available to you. And we're going to use parallelogram RSTU in order to find the measure of the value. Here's parallelogram RSTU. Take a look. What do you have? Here's some numbers.
Angle.
Oh, you have angle.
Angle measurements. Do you have any side measurements?
No.
Yes.
See, 4
Yes.
minus 1.
4b minus 1 and 23. What else do you have?
The
The
arrows.
parallel.
The arrows, so it tells you for sure those sides are parallel. What else do you have?
The bisectors.
You have these diagonals that
Oh, you
bisect.
have a midpoint, right?
Yeah, and there's going to be some midpoint action happening here. All right, let's look at what information we're being asked to find. Of those 4 pieces of information, what do you think would be easiest for you to find right now?
Measurement
B.
RST.
B, I think B. Because
B?
it's just solving for it.
Okay.
Solving for B.
Anna feels that B would be easiest for her to find because it's just a solve for B thing. What information would you be using to complete number 8?
4b minus 1.
23 equals 4B.
Why 23?
She's setting these, yeah, why 23 he wants to?
It's the other parallel side.
Because it's the side opposite.
Yeah.
That's racist.
It's the side opposite, and according to our properties, opposite sides are congruent. All right, get that set up. You can handle number 8. You can tell her later.
Oh, I get it. I get it.
Do it. All right, what other thing do you think could be easy to find?
Measurement.
Of which one?
angle STU.
Of measurements of STU. Why would measure STU be easy for you to find?
Because 25 and 30 is on the opposite side, so if you add those and then flip it over, then that's going to be the total,
What she
or
said.
the whole angle.
What she said. Okay, so let me try to repeat what you said, see if I get it right. She said that it would be easy to find angle STU because I have information about angle SRU here on the opposite corner. And if I were to add these two values, 25 and 30, that value is the same as this entire corner's value over here.
I don't get it.
And that comes from our property that opposite angles are congruent.
Oh,
have
so
the
30
same
side,
measure.
30 side.
Miss, are we gonna do proofs for
Mm, Just wait. All right. Using that information, do you feel that you could handle the rest of this, finding
No.
RST?
No,
Yes.
RST sounds hard because we don't have any information on angle, RST,
We do.
or RU.
Okay, he's saying that we do. Can you
have
tell
an
us?
angle measure and a length.
You have angle measure and you have length of sides. But let's look at this for a second. We know this entire angle, yes?
Yes.
And now we know this entire angle, yes?
Mm-hmm.
Which properties allow us to connect this entire angle with this entire angle?
Consecutive,
Yeah, consecutive angles are,
seven
which means,
next to each other,
and they add up to?
180.
Very nice. So if you know that these two are next to each other, and if I were to add them to get 180, I have some amount here. What do I do in order to find the missing amount?
Wait, so angle SRU is 55.
Yes.
So then I would do 55 plus 55, subtract that from 180, and then the answer that I get when I subtract, I divide it by 2, and that's my R.
You kind of overcomplicated just a little bit. I think a couple more steps in there that might not have been needed. Definitely the idea that we add these two together to get 55 is powerful. Just remember that whatever this corner is plus whatever this corner is will give you the 180.
Okay, so 55 actually.
Yeah, 180 minus 55.
Oh, what was that? Something.
All right, do you think you can find number 7?
Yeah.
Yes. Once you have that measurement there at RST, you have TUR. Very nice. Let's look at questions 9 and 10 briefly. What are you being asked to do?
Plot them.
Plot them, and then what?
And
And then you
then
find the coordinates of the derivation of the diagonal.
Intersection. Find the coordinates of the
Intersection of the diagonal of square or rectangle PRYZ
parallelogram. Yes, where are you going?
with the given
Vertices. Very nice. So you know that you're going to draw that, mark those vertices. I'm going to highly recommend, please, that you label the vertices so that you know which is which. And then use a straight edge, okay? So bust out that straight edge. Thank you. So that way you can make those lines really crisp. Otherwise, your intersection might not come out in the right spot. All right, here's question number 11 at the very bottom of the page. Please scratch it out. We're not doing it on this assignment. Yeah, number 11. So if you haven't scratched it out yet, please do so. It's at the very bottom of that page. Clearly, there's a formatting error.
should we get a phone?
And scratch it out at the very top of the next page. I don't even, like, I don't know. I don't even. All right, let's look at number 12. Read through number 12 and tell me what word does not make sense.
Number 12.
herringbone.
Herringbone. Okay.
Bone.
All right, so let's go to Google
Let's go.
and let me turn down my brightness a little bit.
Turn up.
Come on, Google. Oh, wait, let's do this. Wait, I have it. Look, this is going to be cool. Okay, Google. What is herringbone pattern? It's that thing.
Wikipedia, the herringbone pattern is an arrangement of rectangles used for floor tiling and road pavement, so named for a fancied resemblance to the bones of a fish such as herring. The blocks can be rectangles or parallelograms.
I don't know.
And I'm going to click images so that I can see a little bit more of them. There we go.
Oh, like tires.
Yeah, like tiles that are kind of slanted a little bit. Because these look like the bones of the fish, the herring fish. So they're literally herring bones. All right, so now we know what a herringbone is. Look back at question number 12. Any other words that don't make sense?
Paving.
Paving stones. Those are the concrete little blocks that you buy, just the block by themselves, and you put them next to each other to make a sidewalk. All right, so what are you being asked to do?
You had to find the right to design a herringbone pattern. You have to find the measurement angle.
Yeah, find measurements of angles. So you didn't really need to know that this is for a herringbone or who was going to do a paving or a sidewalk or anything. It's extra information.
Okay, so 130
Oh, that's
is
easy. You just don't use the
insure
180.
angle 1
Yep.
is 130 minus
And
the
the
measuring degree is 130 also.
Bam, you got it. All right, go ahead and write your notes for that one on how to do it, and let's look at 6.3. 6.3, we don't know if we have parallelograms or not. We're going to have to figure it out. So look at questions 1 through 4. What are you being asked to do?
we have to determine whether it's a we
Alright,
use
then
our
look
notes for that.
Yep. And basically your answers are going to be yes
Or no?
or no. Yeah, that's it. But look at the next sentence.
Yeah, miss, which one is that one?
6.3.
Oh, no, miss.
You have to
Okay.
justify. So yes, it is because, and then go to your notes and grab one of the properties that you use to say yes. Yes, because opposite sides are parallel. Yes, because corresponding angles are supplementary. Whatever property you use to say yes. And if you're saying no, you need to state that it doesn't hit all of those properties, or what property you looked at that broke it. Okay? All right, let's look at the bottom ones, 5 through 7. Now you want a graph, and I didn't give you graph paper on this one. I'm very sorry. Oversight on my part. But if you have graph paper, I'll look in the closet a little bit later and see if we can find some graph paper for you. You'll want to graph each of these quadrilaterals, and then determine whether what you're looking at is a parallelogram or not. So again, a yes or no kind of answer. But you have to justify it. Look at number 5. What are you using to justify? Slope formula. You remember slope formula? No?
Y equals mx plus b.
That is point slope form of the equation of the line. Very
Yes,
nice.
very long word.
It was a long time ago. Here's how you use slope, how you calculate it. So back here in 3.3 in October. Now, how could you use the slopes of these sides in order to determine whether it's a parallelogram or not? Let's look at our parallelogram properties. What information possibly deals with slopes? That they're parallel?
No.
That they're congruent
With the slope.
with slope? It's definitely not congruent because that's a distance thing, yeah? Okay, opposite angles? No, because we don't have any angle information.
Because they get it. It's
No.
arbitrary.
Diagonals bisect?
No.
That's a distance or a midpoint kind of thing.
Consecutive, because then we have what
So,
But we don't have any information about the angles. All we're going to have are sides.
oh, the sides are parallel. So then we have, if we get one thing.
It has to be parallel to another. But what are the slopes of parallel lines?
They
What
have the
must-
same X, right?
They have the same slopes.
Parallel lines is like the same thing.
Yeah, here it is. For parallel lines, slopes are equal.
So
So, yeah, so once you've drawn this figure, you're going to use slope formula on those opposite sides. And just see, do I have the same slope? Yes, this thing's a parallelogram. Do I have the same slope? Nope, it's not a parallelogram. That's how you're justifying.
Okay.
All right, look at number 6. Again, you're going to draw it. Again, you're going to make a guess. And then you're going to justify it using slope. You already know how to do that one. And distance. How could you use distance to help you decide if this thing's a parallelogram or not?
Oh, the rest of the other ones that are in the line.
Yeah, look, here's distance formula. There's our distance formula. It looks complicated, but it's just this formula here at the top. That's going to tell you the distance between 2 points. Of your properties for parallelograms, which one can you use the links of sides to help you figure things out?
Opposite sides of parallel.
That's definitely using slope.
Oh, espérame. Opposite sides of congruent.
Opposite sides are congruent, which means if the distance on the sides opposite each other are the same, they're congruent. See how to do that? All right, look at number 7. Number 7 wants you to use what?
What?
Midpoint. All right. So which of our properties will allow us to do something where midpoint becomes helpful?
No, I think you do a formula.
The bisector. Because bisector hits right at the midpoints. Shh. And if we can find the midpoints of those diagonals, if they're the same, we know that those diagonals bisected each other. All right, so you have enough information now to get through 5 through 7? Okay. Look at 8 through 11. Look familiar?
Oh, like the 16?
Yeah, just like the stuff on 6-2. All right, so let's look at number 12. This assignment's number 12 was number 11 on the other one. This is the one that got formatted weird. So you're going to need to write a 2-column proof. What are you given?
PRSC and PQBU.
And the little symbol in front of their names means
That they're
parallelograms.
Parallel.
They're parallelograms in particular. Okay? Which means we get to use all these properties again to help us with our proof. So have your properties ready to go, and your reasons would be property of parallelogram. Okay? Because it's one of our properties. What are we trying to prove?
That angle V is equal or congruent to angle S.
So angle V is congruent to angle S. Look at your setup. What properties could you use to relate V and S somehow? This does look like a dilation, and you're not wrong about that, but dilation doesn't help us show congruence yet. Yeah. But I like that your mind went there. Thank you.
Base angles and congruent.
Base angles are congruent. That would be if we were looking at a trapezoid.
Well, if we can prove that PR is congruent to TS and PQ is the midpoint, then that would make
Yes, I know what it is. I know what it's called.
Like I know how to.
Okay, I see where you're going with it. You're trying to get these segments to be congruent
Yeah,
and stuff.
And then if
Which
those
I
are all
do.
congruent, then UV.
Wouldn't that be like a circumcenter or something?
Could this go to circumcenter? If this were triangle, then possibly we could use circumcenter.
What are
Yeah.
we doing anyways?
We're trying to prove that V is congruent to S. The thing is we're trying to prove that angles are congruent. Yeah, we want to look at the angles. So which angles are you looking at?
Would
D and
we
P,
can
V, and S,
And then P and S,
and then P and S. So why are P and S congruent to each
because
other?
they're in the same parallelogram and
And the
both are
congruent.
cubes.
What's the property in parallelogram that
Opposite
tells you?
opposite angles are congruent.
Do they have all?
So you can state that P and S are congruent to each other. Which other two angles can you state are congruent to each other?
Because opposite angles.
P and V for the same reason, properties of parallelograms. Now, how do we get V and S to be congruent to each other if V is congruent to P and S is congruent to P? You remember which property allowed us to say that?
Equality?
It definitely is going to feel like equality, but there's actually the property of congruence that allows us to say it. And that's the one we want to use because we're dealing with congruence right now. I'm trying to find it in our notes. I know where it is, I just have to flip through. Here we go. So here are properties of congruence. Which of these properties could help us get that V and S are congruent to each other? Knowing.
Transitive.
Yeah, transitive. All right, so you have all the pieces. Now you've got to fit them together in a way that makes sense. 2 columns. I gave you way more lines than you need, just saying.
So you have to write the given first.
Yep, given first. Make sure that your proof statement is the very last thing you do. Make sure that each statement has a reason. Look at question 13. Turn the 2-column proof that you just wrote into a paragraph proof. This is as simple as write the statement, write the word because, and then write the reason that went with it. You don't have to make it more complicated or fancy than that. But look at the requirement I'm giving you, the restriction.
Do not use abbreviations or mathematical symbols. Also, if it's like congruent, we have to write congruent.
Yes, so if you look here at the prove line, you see this symbol right here in front of V?
Do numbers count?
Numbers do not count as mathematical symbols. You do not have to write out numbers. But this little symbol here in front of the V that stands for the word angle, you have to write out the word angle. And this symbol in here between them that stands for is congruent to,
You have to write is congruent.
you have to write out the words is congruent to.
Oh, I never put 2, I just put is congruent.
Depending on how you format your sentence, that could be grammatically correct. So it just depends on again, how you decide to format. All right, any other questions that we didn't cover over this homework? All right, thank you very much.